So the program statement is write an embedded C program to interface switches, relay and buzzer and also LEDs to microcontroller. So we have to write a program such that when switch 1 is pressed, relay and buzzer should be turned off and LEDs should chase in one direction. And when switch 2 is pressed, relay and buzzer are turned on and LEDs chase in other direction. That means we have to shift the lighting of LEDs in right direction in one case and left direction in other case. So just go through this simple flow chart. We'll start of writing a main program. The first step always in writing an embedded C program is initialize the port. That means decide the direction of port terminal, whether you want to use port terminal as an input terminal or as an output terminal. So that is initialization of port. And then we'll check whether key is pressed by user or not, whether switch 1 or switch 2 is pressed by user or not. If key is pressed by the user, we'll proceed, but if key is not pressed by the user, then we'll continuously check whether key is pressed or not. If key is pressed by the user, then we have to check whether switch 2 is pressed by the user or whether switch 1 is pressed by the user. If switch 1 is pressed, then we'll use LEDs should chase in right direction, and at this time relay and buzzer both will be off. If switch 2 is pressed, then LED will chase in left direction. This we have selected, and relay and buzzer both will be turned on. So this chasing of LEDs will do 8 times. So we'll repeat this block 8 times because there are 8 LEDs. So all will glow while chasing in right direction or left direction. And after shifting these LEDs in left or right direction, again we'll check a status of key, whether key is pressed by the user or not, and we'll continue this process. This is the interfacing diagram as per the board shown. Here RA4 terminal is used to connect the relay. So relay driver is connected here. We can connect any device here, bulb or any other device. The relay is normally open. So when current will flow through this relay, it will close. This relay operation we have discussed while interfacing relay with 8051. Same for buzzer. Buzzer is connected here at pin RD2. The connection of buzzer is such that when 1 is given to this RD2 terminal, buzzer will be off because second terminal of buzzer is connected to VCC. So whenever we'll provide logic 1 through RD2, the both terminals will be at same logic level, so buzzer will be off. But when we'll send the logic 0, the second terminal will be connected to ground and buzzer will turn on. For relay, when we'll send the logic 1, then this transistor will turn on, current will flow through this coil and this switch will be activated. And when we send the logic 0, the transistor is off, so current won't flow through this coil and switch will remain in off condition. The two switches, switch 1 and switch 2, are connected to RD0 and RD1 terminal. And the LEDs are connected to port B, RB0 to RB7 terminal. So this is interfacing diagram. As per this interfacing diagram, we'll write a program. So first include this file p18f4450.h. So all information about the registers, memory locations of this microcontroller are stored in header file. So we'll write a simple delay program, the same delay program which we have used for LED flashing is used here. Then we'll start writing a main program. So here I have used some variables. So like a I variable, key variable is initialized with 0. This p variable is initialized with 0x0 of 1. So these variables we can use in our program. So first we'll decide the direction of port B where we have connected LEDs. So this port pins we will use as a output port pin. At terminal D0 we have connected switch 1. So here we are initializing it as a input pin, and D1 pin again we are using for switch 2. So it is also initialized with 1. This trace resistor is initialized with 1. So we are using this as an input port pin. At D2 RD2 terminal the buzzer is connected. So we'll use this as a output terminal. So it is initialized with logic 0. Then RA4 terminal is used to connect a relay. So again we'll use this as a output terminal. So two switches, switch port terminals we are using as a input, and other port terminals we are using as a output. So all these are initialized here. Then we'll check whether key is pressed by user or not. So for that we'll check this D0 port terminal. If switch is pressed by the user, then D0 port terminal will be at 0. You have already studied this operation of switch. When switch is pressed by the user, 0 will be connected to port terminal, and when switch is open, 1 will be connected to port terminal. So if RD0 is 0, then this variable key is initialized with value 0. And if RD1, that means next second switch is pressed, then the key variable is initialized with 1. And then we'll check the value of key variable. If key variable is 0, it indicates that switch 1 or button 1 is pressed. And if key variable is 1, then button 2 is pressed. So here we'll write the instruction if key is equal to 0. So if key is equal to 0, this variable p is initialized with 0x80. Why it is so? Will send this data initially to LEDs. So what will happen? This LED will glow and all other LEDs will turn off. So initially we'll send this data to port B. So this LED will glow and all other will turn off, and then we'll shift this one in right direction. So it will be like the chasing LED in right direction. So first this P variable is initialized with 80, and we know that when switch is pressed as per our flow chart, then we have to turn relay off. So to turn relay off, we have to send logic 0 to RA4 terminal. So relay will turn off, and to turn off buzzer, we have to send logic 1 as per the interfacing diagram. So after doing this, here for loop is used because we want to shift this 1 in right direction. So this P, initial value of this P is placed on port B. So at the LED will get this status. This LED will glow and all other will turn off. And after that, this data will shift in right direction. So what will happen? This LED or one bit will shift in right direction, and we'll see the blinking of LEDs in right direction. And then we'll call a delay. So what will happen on LED? First, this LED will go glow. So what will happen here at LED side? This LED will glow. After delay, this will glow. After delay, this will glow. So it is like chasing LEDs in right direction. So we are shifting this data, initial data, by 1 bit. So this is the shift operator used in C. So we'll shift this data of P in right direction by 1 bit. So this instruction is used and we'll call a delay. So 8 times we are going to shift in right direction, and after that again, since it is written in while loop, it will check whether the key is pressed by user or no. So we'll complete this for loop and this if loop also. This is for the switch 1, if switch 1 is pressed. Now if switch 2 is pressed, that means if key variable is 1, then we initialize this P with value 0x01. That means now the LED will chase in other direction. That means this 1 will shift in left direction. So we'll initialize this value with 0x1. Then the relay should be on. So at RA4 we'll send a logic 1. Then buzzer should be on. So at RD2 we'll send a logic 0, and again for 8 times we'll repeat this. At port B we'll send this initial value, that is P, and we'll shift P in left direction by 1 bit 8 times. So it will be like this. This 1 is shifting in left direction. So LED is chasing in left direction, and we'll call a delay. We'll complete the for loop and then if loop, and then complete this while one loop and the main program. So this program can be used to interface switch, LEDs, relay and buzzer.